I just want to talk to you very, very quickly today about graphing sine and cosine curves. And I know you guys have already done this a little bit anyway, so a lot of this will just be really quick review. But we do need to talk about some of the similarities and differences of the sine and cosine curve. So always on the x-axis of your graphs, it's always where you're going to have the degrees. And you guys so far have graphed, every step on your graph was 90 degrees. You remember doing this?
Yeah.
90, 180, 270, 360. And then when you go backwards, that's as if you are rotating backwards around the circle, which actually backwards means you are moving in a clockwise direction, which seems kind of backwards, but that's what's happening. Now, you have to, when you're graphing a sine and a cosine curve, you have to figure out how high should you label your y-axis and how low should you label your y-axis. So yesterday we graphed something that had a radius of 15. It was a Ferris wheel with a radius of 15. How high did the graph go? 15. How low did the graph go? Negative 15. So what if the radius is 20? How high are you going to make your y-axis go? 20. How low are you going to make it go? Negative 20. It's really that easy. So you just need to, if you know the radius, then you know how high to graph it. Okay, so let's say that I am asking you to graph a cosine curve. So y equals the cosine of x. And it has a radius of, I'm just going to make a number up, let's say the radius is 7. The radius is 7, you know that your graph is going to go up to 7 and is going to go down to negative 7. So you go up to here, you go down to here. Yes?
Yes, correct.
All you have to do now, by the way, what's halfway between negative 90 and 90?
45.
0. Halfway between 0 and 90 is 45. Halfway between negative 90 and 90 is 0. So what you need to do is just, on your calculators, type in cosine 0. So what are you going to do to your answer?
Times it.
You're going to multiply it by 70. I mean, 7, not 70. Because it's not, because the radius is 7. So you're going to go cosine 0 times 7. What do you get? 7. You get 7, so you put a point up here. And then you need to do the same thing for 90. Do the cosine of 90. Get an answer. And then multiply your answer by 7. What do you get? 0. Now, let me show you a quicker way to do this. Because the radius is 7, all you are really doing is this. You are graphing a curve with an equation, 7 cosine of x. So if you type into your calculator 7 cosine 0, you're going to get a point. Plot it. Then you go 7 cosine 90. You'll get 0. Plot it. Then you do 7 cosine 180. Negative 7. Plot it. You're right here at 180 or down at negative 7. That's all you have to do. And then you continue going. Then you go 7 cosine 270. You will get an answer back at 0. 7 cosine 360. You will be up at 7.
Is it always going to do that for cosine?
Yes, it will. Always do this for cosine. Remember, you are doing curves, not teeth. Okay? What about when you move this way?
7
So just type in a negative. 7 cosine negative 90. You will be right here. Exactly, for the cosine curve. And my concern is when we start talking about sine curves. We'll all address that when we get to it. This is a cosine curve. Alright, and then you go like this. And you guys are going to have to do this by yourself. This look, I did a really bad job of that. So this will be a nice pretty curve there. Alright, so I would like to switch gears here for just a second and talk to you about what happens if you have sine curves, because there was a lot of confusion yesterday on the assignment. I graded your papers, and there were the same mistake. I saw the same mistake a lot. So if you are graphing a sine curve that has a radius of, I'm going to change the radius now. I'm going to say y equals the sine of x. That has a radius of, I'm going to say the radius is 10. So what am I really graphing? If it's a sine curve with a radius of 10, what are you really graphing?
10 sine.
Yes, the radius, in other words, always goes in front. Radius comes first, then what sine or cosine, whatever it is that you're working with. So, you do this. You type this into your calculator just the way you see it. 10 sine 0. What is 10 sine 0? It's 0, so you get a point right here. 10, now go to 90. 10 sine of 90.
10.
It's 10. So if this distance is 7, I'm going to go up a little bit further and say that's 10. So we go 10 sine 90, we're up here at 10. Then we do 10 sine 180, we're back at 0. Then we do 10 sine 270, we're down at
-10.
-10. So I'm going to go down here and say that's -10. And then at 360, we're back at 0. And you should see this nice curve. And this is where we need to start getting a little bit more serious with our conversation. I saw a lot of people do this perfectly yesterday. It looked really nice. But then they started working this way, and they thought that the sine curve was a mirror image on the other side of the y-axis. But the problem is do you see how it goes up, and then it goes all the way down, and then it goes up? Well, if I am working backwards on this sine curve, I go all the way up. I have to go all the way down before I go back up again. So the sine curve is not symmetric with the y-axis. Does not have reflection symmetry with the y-axis. So I'm actually going to be down here. So for those of you that are a little sketchy on that, make sure you're checking every point. You're going to have to type into your calculator 10 sine negative 90, 10 sine of negative 180, and so on. And this is what's going to happen. I saw a lot of people yesterday, once they got to here, they went back up again. They didn't go all the way down before they headed back up. Does that make sense? All right. You can stop the video. Thank you.